Hello. Hi there. Can everybody hear me okay? Hi there. Welcome to Goto 10 and for Tech Tuesday. My name's Aaron and I work here at Goto 10. I help with the events here when we have live events or we have live streams like we have today. And we are run by Internetstiftelsen, which is the Internet Foundation of Sweden. And they work a lot with knowledge sharing and promoting innovation. And we are our co-working space and an event space. So that means that if you want to come here to use our co-working space, you're very welcome to come. It's a free membership. We're open 8 till 4:30, Monday to Friday. So please, if you have any questions about the space, talk to me. I can help you become a member. I can show you around. And you can have a look at our facilities to see what we have. And maybe, yeah, you're welcome to join. I see some members here already, so that's good. Talk to them as well. They'll tell you how great the place is. So, yeah. So, just want to welcome you today, and I'm going to pass you over to Anna, who's going to introduce the event today. Thank you.
Thank you, Aaron. And also from my side, a very welcome to today's Tech Tuesday. My name is Anna Broders. I work as a talent and community manager at Linköping Science Park, and I love to gather people. And I think this really today is a good example of this. We are amazed of the interest of today's Tech Tuesday and very happy to have you all here. It is a bit squeezed and tight, but I hope we will manage. Also very welcome to all of you joining us digital. Tech Tuesday is a concept driven by us in the Science Park together with Ericsson, Sectra, SICK EVP, Combitech and Near Dynamics. And every third week, we invite you all to this Tech Tuesday, where we share knowledge about techniques that are working with in the Science Park. And today we have a bit of a Tech Tuesday special, and this is an opportunity to invite other tech companies than the 5 working together in Tech Tuesday. So we're very happy to have UMS Skeldar with us today, and Ola and Henrik, who will talk more about this one, the Skeldar V-200. So they will have a presentation, and afterwards there will be time for questions. So please think about that, save your questions, and we take them afterwards. Henrik and Ola, the floor is yours.
Thank you. Sound okay? Perfect. Yeah, okay. Thank you for the invitation, first of all, and nice to see so many people here. So my name is Ola, and with me I have my colleague Henrik, and we will hold this presentation together. So the plan is that I will start by talking about 20 minutes about our company and focusing on the product, the Skeldar V-200 UAV system, and also about which kind of technology areas you work within as an engineer at Skeldar. And after that, Henrik will have a live demonstration of our training simulator. So fingers crossed. Let's see. Battery running low. That's a good start. Here we go. Okay. So let's get straight to it. In this picture you see the Skeldar helicopter carrying a big state-of-the-art marine surveillance camera. So a big camera gimbal that you can turn and tilt and zoom on different things to get the information. And this is really what it's all about. We make different kinds of sensors fly. So you as a customer, you have some kind of sensor or in general a payload that you want to get airborne to collect some kind of information from the air. And what we provide is a flying platform in the shape of this unmanned helicopter that can get your sensor so that you can collect your information. We also develop a complete ground control station from where you can interact with the helicopter and also with the payload. So that in a nutshell is what we do. There's a variety of different sensors that you can think of to be relevant to put in the air. The most common fundamental one is a good camera. And they come in different shapes, and there are different suppliers of these cameras, and we integrate cameras based on the needs of our customers. These are daylight cameras, typically in combination with infrared capability, so you can see hot objects as well. But then it's really just the imagination that limits what you can put on this thing. So here's a combination of a camera and a smaller radar to find ships, etc. You can think of completely other applications. You can drop things from the air. In this case, just a sandbag as a proof of concept. But you can also think of more useful things to drop, like sonar buoys, if you want to know what's going on under the surface of the ocean. There's another category if you want to know information about the air around the helicopter. So this was a weather reconnaissance pod that we integrated for a customer. And another example in this area is this. You can see a long tube sticking out in the nose of the helicopter, and that's connected to a gas sniffer, so you can real-time analyze exhaust gas from ships, and I will come back to that. So this is the air segment, and on ground you have the equivalent of a cockpit in a manned aircraft. So our cockpit consists of 2 workstations. To the left, you have the pilot. We still call it a pilot, even though it's a remote pilot. So in this case, Lucas is controlling where the air vehicle is going. And you don't need any helicopter piloting skills to do this. It's just a matter of pressing buttons and clicking in a map. And this is what Henrik will show you a bit later. The other role is the payload operator. So in this case, Sophia is interacting with the payload, steering it, and gathering real-time information that you need for some reason. So that's so we developed this, and then we integrate it in different ways depending on the customer need. So it can be a trailer, like in this case. It can be a van, like this, if you want to follow or ride along with the helicopter. And it can also be in a ship. And this is really the key market segment for us at the moment, to integrate our system, ground control station and helicopter on board ships, like in this case, the Finnish Coast Guard. Okay, so in a military scenario, the use can be like this, that on board the ship you have different sensors, so you have radar systems and you put them as high up in the mast as possible, but they still give you a limited range. And this is illustrated here by this yellow circle around the ship. But if you put a Skeldar up in the air equipped with a sensor, that gives you much larger range, where you can get information about what's going on, both in the air and on the surface. Here's a civil application. I talked about this exhaust gas sniffer as a payload. This is what it can look like in the ground control station. We had a project with the EU, so we were launching from the coast of Denmark, and in a strait there were a lot of cargo ships. And EU wanted to control or measure the contents of the exhaust gases live to see that they meet the regulations that the EU set up. So here live we would seek up different ships, sneak up behind them, fly in the exhaust gas plume, and in real time we could get carbon dioxide, sulfur, nitrogen, NOx, etc. There was a Danish company that developed this sensor in this case, and we integrated it. So a couple of applications. So why should you buy a Skeldar? I mean, there are other types of air vehicles. So here's our market, our area, our niche. So if your payload weighs somewhere between 20 to 40 kilos, and you want this thing to be in the air for quite a while, so up to 6 hours flight, and quite a range, so up to 100 kilometers. In this case, this rules out all your hobby-size drones. I think all these, both weight, flight time, and range. And if you have a fourth criterion, which is that you don't really have a runway, so you can't use an airplane, then you kind of end up at a helicopter. And if you also want it to be unmanned, either for safety reasons or for economical reasons, then you kind of end up with a Skeldar-sized helicopter, unmanned. So this is sort of the niche within all the aircraft that are out there. This is what we are targeting. And worldwide, we have essentially one competitor. It's an Austrian company developing a similar product. So we meet them in all contracts, competitions. Okay, so here's a short video that gives you some feeling for what it can look like. This was a demonstration on board a Finnish Coast Guard, which was a EU-sponsored evaluation of different UAVs. So we participated, and one part was to evaluate the operational capability for different missions. So that was quite successful. So that was about the product. And now just a few words about the company. It all started for the Skeldar in 2006, when Saab decided to acquire some of the technical rights for another helicopter that already existed, developed by another Linköping company, Cybero, who actually had their offices in this very building for a while. So based on their APID 55, Saab during the next number of years, and Christer here, for example, was part of that journey, we developed first kind of a clone, the top one, the Skeldar V-150, and then we decided to make a sort of extreme makeover of all the parts in the system, and ended up with the Skeldar V-200 design, pretty much as it looks today, even though the interior is constantly changing. The next milestone that I bring up is 10 years later, when this previously Saab internal project turned into a company of its own. And this was via a joint venture between Saab and a Swiss company called UMS, hence the name UMS, Skeldar, and UMS stands for Unmanned System. So me and not so many colleagues left Saab and tried to start a brand new company with facilities in Hackefors, quite near Motorstadion, where you can go driving go-kart or something. And we've been growing ever since. And we also then joined with the UMS in Switzerland, who had quite similar development. So in the background, in the bottom picture, you can see there, confusingly also called the Skeldar V-100 helicopter, but had a completely different history. So for a number of years, we developed quite similar products in parallel, aiming for slightly different market segments. The next milestone was actually just a couple of months ago, when two things happened. The first one was that the company decided to cancel the development in Switzerland. So leaving the development of the V-100 due to simply economical reasons. And the second thing that happened was that Saab acquired the whole company. So we're once again sort of under the Saab hat, but still a company of our own. So we're back to developing only the V-200 system. So that's the whole focus from now on. So it's me, Henrik, and according to Linnea, about 148 more people, in total 150, working primarily in Hackefors. We still have some people left in Switzerland. Okay. Commercially, we have two public contracts. One is with the German Marine, where the Skeldar is operational today, off of one of their ships. And the second contract is with, it's a joint contract with Belgium and the Netherlands, and this is to be delivered, but it's also a marine contract aimed for, well, some kind of advanced mine sweeping. And Magnus is here, our program manager for that, so he can tell you all about that later if you're interested. So as you can see, focus on military customers at the moment. So what do we do at Skeldar, us engineers like me and Henrik? So some of the key technology areas, we do complete mechanical design of the helicopter. Of course, we buy a lot of parts like the engine, but we do complete design of rotor system, frames, etc. So a lot of mechanical engineers. We do complete development of the ground control station, both specifying the hardware and also doing all the software development and implementation for the different applications that are running in the ground station. A big part is of course payload integration, so different for each customer projects. It's always nice if you sell the same payload twice to different customers, but typically that's not the case. So we do mechanical, electrical integration, and also integrate the control of the sensor into our applications. So you can see in the middle view up there that you get the payload camera view into our application, so you don't have a separate application for the payload operation. Communication is of course vital. If you have an unmanned vehicle, you need to have robust communication as much as possible at a long range. So in the bottom there you can see our primary link. It's a neat thing developed by a Norwegian company up in Trondheim. Navigation is also a big area. If you don't have a pilot on board, where are you? And we are still heavily GPS or GNSS dependent, but having military customers, of course, is of interest to be robust to GPS denied situations, as you can read in the news now and then with conflicts going on. And that's quite tricky. Of course, there are a couple of different options we are pursuing. The communication link over there is actually a directed link. So the units know where they are in relation to each other. So if you know where your ground station is, you can sort of compute where the air vehicle is. So that's a neat form of navigation. And for precision ship landing, Airbus have developed a system called Deck Finder, which allows you to do precise GPS-independent navigation in really tight spaces. It's like a local radio-based navigation system, like a GPS on land. And the final area I want to highlight is my area, flight control. So we do complete flight control development, all the way from low-level control of the rotors, all the way up to some basic autonomy if you lose your communication link, for example. And one of the most challenging / fun things is to develop control laws for landing on a moving ship, which we have proved a few years ago. Okay, and with that I will leave the word to Henrik, who will talk about how we have integrated all these things into a training simulator.
Yeah, can you hear me? The microphone on? Can you hear me now? All right. I thought give a brief overview of my area, the simulator, but we don't have so much time left, so I will keep it really, really short. So I'm not sure how much I will use this slide, but we have one variant of our simulator with us today. It's what we call the desktop trainer. That's these two laptops that you see here. And what we have done is we basically took the software from the helicopter that runs in the helicopter and put it on that one. Really simplified. It was a bit more complicated than that. Together with our simulator. So the simulator and the FCU software, like they are communicating with each other. The simulator is simulating the surrounding of the helicopter, all the devices that the helicopter has and this, the FCU is communicating with. So all the data that comes in and the data that goes to the devices. Then we have a small UI, so you can control your simulation. You can set start parameters like your starting position. We have a little boat that we can control, so we can also set where the boat is. You can inject faults, so when you educate new pilots or like train new pilots, like an instructor can trigger some faults and see how the student reacts. So we have the GUI to control all of that. So that's also why we call this one the instructor PC or instructor station, because usually in pilot instructor sits there. And then with the other laptop, we basically took all the software that we have in the ground control station and put it on that one. So there we mostly have actually the same binaries that we have in the ground control station and run it on that. And let's go to the next one. As you see, usually it's like two operator stations. We just have one here now. And let's do it like this. Yeah, so we took basically one side of it and make it run on a normal PC. And what you have in like the remote pilot station to control the UAV, it's like you have one PC that's sitting here, what we call the flight panel. That looks basically like this, and you can already see it looks a little bit like a cockpit from a manned aircraft. So you have like some information about which direction you're flying at, which height you have, which speed you have, and you can control the helicopter in the most simplified way. We will see that in a bit when we demonstrate it. And then on top of this, it's a screen to another computer, And there we have all the tactical function, what we call it. So what's critical for a mission. So the flight panel is critical for flying the helicopter. Everything else is like critical for do something useful when you are flying. And this looks like that. So on the left here, we see that we have a map with the area where we operate. On the right, you have a camera footage from, we have a camera in the nose of the helicopter. And you can also switch to the camera under the helicopter so you can look around. So this is usually what the payload operator works with. And as you can see, we slide it a little bit off the ship. So I will just restart the simulation. Right, let's see. So now we are standing on the landing deck. So this is basically how we set up our simulator. We have one instructor station with a simulation and a little bit, and then we have one where the student sits. Okay. Let's fly around a little bit. What we see here on the left is what we call our high-level commands. It's like buttons you can usually press. And for example, we can start the engine here. And then we wait a bit, and we can see the engine is starting. We have like 1,600 RPM. And so you have like this high-level commands to control the helicopter. Then we have like this knobs that you can turn to control different aspects of the helicopter. So to be able to make a takeoff, we have to go to flight RPM. So we have a little menu here that you can control with a knob. And you can set the engine to flight RPM. So for the simulator, we had to create this GUI around so you are able to use these knobs, because in the real system, as you can see, they're actually physical knobs that you can press. All right. I will set some speed to the ship we are starting on. And as you can see, we have the engine running. Now you might think you're able to start, but you don't. You can see the takeoff button is grayed out, so you cannot do a takeoff. Why is that? To do a takeoff, you have to be what we call tethered to the ship. And that you can do with this button. It's a function where the helicopter is automatically following the ship from the position where you activated it. So when you do a takeoff from a ship, you want that the helicopter is following the boat, same when you land. So you don't want to do a takeoff and then the ship goes away and you stay behind the ship. You want to get smooth up and follow the ship for that moment, the same when you land. And we see now that we are tethered, the takeoff button becomes white, indicating to the pilot, okay, now you can do a takeoff. So let's do that. And let's see what's happening. So now we're doing the takeoff from the ship with just like one button press. All right, and then you can release the tethering, and you can see the ship is moving forward and the helicopter stays where you release it. And now you can actually flying around with a helicopter. And we have 3 different ways to do that. So the first flight mode we have is like, again, with these knobs on the flight panel. So I can rotate it and set a new height to the helicopter, indicating with like this little arrow. And if I press it, the helicopter will automatically adjust the height to it. And the same with like the heading, so you can turn the helicopter, and the same with the speed. So you can this mode is called vectoring mode. It's also from aviation, where you usually get a flight vector. So you can set your flight vector as like these 3 options and fly the helicopter like the easiest way possible. So this is the first way to fly the helicopter that we have. It's called the vectoring mode. Then we have 2 others. The other one is point and fly. It's the first mode is good for flying in a certain direction. But if you want to fly some more complicated maneuvers, it's not really good. You have to like turn the knobs all the time. It's the workload for the pilot is too high. So we have a second mode that we call point and fly. So what you can do, you can click with the mouse somewhere in the map, set the point, and then one sec. You can set just the point in the map and command that the helicopter should fly to this position, and the helicopter is doing it all on its own. So it's calculating, okay, how do I have to fly to get to this point? And this mode we call point and fly, because you point to a map and then the helicopter flies to it. Then you can also, at this point, set what we call loiter pattern. So you can command the helicopter, okay, when you are here, start flying in a circle, or start flying like an 8. Because usually when you are looking at something, you don't want to be still with a helicopter. That takes a lot of fuel. It's more economic to keep flying with a certain speed. So that's why we have the option to fly this kind of loiter patterns. So when you command it, the helicopter calculates, okay, how do I have to fly to get to this pattern, and then starts flying it. So this would be the second flight mode we have. And the third way to fly the helicopter is you can also in the map set waypoints and create a route. And then you can upload the route to the helicopter, and then the helicopter has this route saved. And when did it work? I didn't see. No. It's the wrong one. This button is the one for uploading the route. So if it's uploaded, it's indicated here with the color, and then you can click on any point of this route and just say, okay, start flying this route at this point, and the helicopter will do that. So that's a third way of controlling the helicopter. Yeah, that was pretty much what I wanted to show. I think we have some time left for questions.
So, well, the questions that pop up. We take the questions in the microphone so the people online also can listen to the question. And if you are online and have a question, please write it in the chat and Aaron will help us give them.
Okay, thank you very much for a very interesting presentation. I have a question. I see that the applications that you have really open spaces. Can you fly in more complex environments? Do you have the technical ability to maintain the same, let's say, do you need the line of sight all the time, or yeah, what are the capabilities of this?
Your area.
Yeah. Oh, well, the communication. Since you're a communication guy, yes, it's line of sight communications. We don't have like satellite communication or anything like that built in currently. It hasn't been a customer need so far.
Hi, Thomas Engelmark from RISE. Usual UAVs, they have follow mode, follow ships, or return home when the GPS is not working, etc., etc. Do you are on par with traditional COTS drones when it comes to functionality?
Well, I mean, we can follow our own ship with this tethering mode that I tried to explain. And then we have something that's called a contingency route. So before you start flying, you create a route, a second one that you upload to the helicopter. And in case you lose the connection to the helicopter will fly this route to its endpoint. And if it didn't get back any connection when it's there, it will land there. So that's, yeah. Hope that answers your question.
Thank you.
Thank you. More questions? We take.
Another question, yes. I see, well, you put all the eyes down to earth, yeah? So you look down. Is there any application that you need to look up as well? I mean, have a vision that is 360 or the whole sphere, because now it's hemispherical, yeah? Do you have?
No, we haven't had that. I mean, we have possibly looking forward. For example, in a sense and avoid, if you're an unmanned aircraft and you want to fly with other aircraft, you need to make sure you don't collide. So have something facing forward, yes, but not up so far.
I think we have a question there.
Maybe a bit stupid of a question, and you might have just answered it. But if I like tell two helicopters to drive into each other, or I tell it to drive into a mountain, will it let me?
Essentially, yes, because you're still the pilot, even if you're on ground. So I mean, you can decide where the line goes. What should the machine decide? What should the human decide? And I would say we have quite so far low level of really autonomy. We're building protection layers more and more to protect from tired humans, we can say. But you're still the pilot, so a lot of decisions. It's also a philosophy that you should never be prevented by the machine. It might be that you have a really good reason to do this command. And then in many situations, it's better to give the responsibility to the pilot than to the machine. But it's always a bit tricky trade-off.
You have some warnings when you approach the ground, or like flying towards a mountain, so the pilot will be warned in time and can then react, but it's still the responsibility of the pilot.
A technical question. Could you tell us a bit about the motivations for the single rotor layout compared to multi-rotor? Because I mean, the performance is impressive with 6 hours of flying time, but still you have energy spent on the tail rotor, which doesn't contribute to flying, really.
Right.
So I'm curious about the motivations behind that.
I mean, it's a really fundamental decision, but as far as I know, single rotor systems are more energy efficient than multi-rotor systems. That's as far as I know, even with a tail rotor not really contributing to lift, but only anti-torque.
Yeah, I was just wondering, since these are flying in normal airspace, I guess, what are the rules there? Are there ever a scenario where the pilot would have to communicate with air traffic controllers and stuff and they are on the ground, but they are communicating as if they are the Skeldar? Or how does that work?
Yeah, I think you're hitting a key area now. Today we're not flying in the same airspace as normal air traffic, but we have we are assigned a subspace where we can be. We're still communicating with air traffic control, but we're not interacting anywhere near other aircraft. So that's, I guess, one of the big journeys ahead to get a broader range of possible applications, definitely. Oh, transponders, black magic. Yeah, you can pick it up on flight radar. It's flying today? Okay, good. Yeah.
And I guess it depends also where you're flying. If you're flying here in Sweden over land, for sure you communicate with the tower. But if you're on the middle of the ocean and fly around, there's no tower.
Any more questions? I know both Ola and Henrik will stay a bit for a while afterwards, and they have colleagues with them as well. So if there are more questions you want to take one-on-one, feel free to stay and talk to them. Otherwise, I would thank you. We start with thank you for a great presentation, really interesting, and a live demo. So we start with applaud with that. And thank you all for coming. Next Tech Tuesday will be the 27th of February with Ericsson as a host. And it will, the topic is how to create value through digitalization in an IoT context. I can't write my own notes. Context was the name. So I hope to see you there. The registration is at our webpage at linköpingsciencepark.se. Thank you very much.